Okay, so thanks everybody for hanging around till the end of the first day of Hadoop Summit 2015. I'm going to be talking about scalable Hadoop on Mesos and with Docker containers. My partner in crime, Chris Muchler, is not able to make it here today, but if you have any questions or comments, you can see, hopefully, you can see our Twitter handles on the first slide here. If you want to get in touch with me or Chris for additional questions, please feel free. So, what I want to discuss is more operations focused than some of the developer sessions. And from last year, Chris and I, talked about a lot of development on the operations side at Adobe for facilitating virtual Hadoop clusters across their environment. And so, new approach, working with Mesos to be able to host those clusters and function as a resource pool. There are three key takeaways for this session is just be able to understand the roles that Mesos, Hadoop, and Docker play together for facilitating developer workflows as well as operations management of not just Hadoop, but the rest of a modern application pipeline, as well as being able to use continuous integration, continuous delivery to enhance the reliability in this model while sticking to a familiar developer workflow. And finally, being able to pick a flexible form factor, again, that's familiar to developers, as well as be able to facilitate that in the Mesos frameworks and with Docker. Now, last year's state of the art, we enabled virtual Hadoop clusters with vSphere. So using VMware Big Data extensions, any developer could provision their own Hadoop cluster. They could pick their template, pick their distribution, pick their size, pick the number of workers that they wanted to deploy, and be able to experiment with that. That's something that the developers obviously could have with a public cloud platform, but Adobe wanted to bring this in-house without restricting their ability to experiment and work with Hadoop and test out different features, test out different pipelines at scale. And also, they wanted to be able to share infrastructure. Obviously, as many developers couldn't have each their own physical Hadoop cluster, so they were still able to share hardware across the environment. Again, this is what VMs do all the time. In a public cloud platform, you're dealing with a VM, but you're just dealing with their form factor. And finally, the blueprinting that we used at the time was with VMware Big Data extensions. I'm going to be talking about that as well as a couple other alternatives for building out the system. So, what are the new goals, taking what we're able to build last year and translate that to today? So we figured out pretty quickly that not everything we wanted to build was going to be in Yarn. Whether in the future, Yarn is going to be that one-stop shop for different kinds of frameworks, for handling different services for an application. We have developers that want to be able to build things today, and they want to be able to pick and choose their framework. Again, going back to experimentation, they want to be able to figure out which framework fits for what they're trying to build in that part of the ecosystem. And so with all these different frameworks, they want to be able to free to revise those. Obviously, for continuous integration, they want to be able to deploy different versions at a steady pace and not have the service that they're building interfere with the revisions or choices that other developer teams are making. So up front, they want to make sure that all of these services that they're deploying are decoupled and ensure that one thing doesn't necessarily break the other, or if it does, be able to figure that out really quickly. As well, working with VMs is not a problem for performance. We can get bare metal performance with VMs. We can get latency sensitive. We can decouple the storage and compute workloads and do really well. But for developers working with VMs, it didn't encapsulate what they wanted to be able to present from a environment and code standpoint. So this is where started looking at Docker, which has grown immensely since the first session was last year from the guys at Sequence IQ talking about their API with Cloudbreak. Now, to introduce Mesos, it was originally conceived out of Berkeley, Ben Heineman, and so graduated as a Apache top-level project. It's still relatively early days for Mesos, but it was conceived along the same lines of Google's white papers around focusing on the data center as the computer. And so Mesos is the single resource pool or a single framework for running other frameworks, whereas Yarn is a framework for running scalable analytics. Mesos is the framework for accommodating other frameworks. Now, in its architecture, of course, in any good distributed system, we have a master node and worker nodes. In order to deploy Mesos, we can have a highly available master with Zookeeper, and on the individual worker nodes can have different executors. So different frameworks that are sharing the same hardware and be able to handle different resource offers from the constituent worker nodes to be able to get work done for any particular framework. So instead of the case where in a typical distributed system, you have a job that has its resource requirements up front, and the scheduler is responsible for either running that job with the resources it requests or waiting, just queuing it up. Mesos actually takes kind of a different approach where resource offers are provided by the individual worker nodes to identify what resources are available at any given time, whether it's the whole node or a subset. And the individual framework can then make a decision whether it wants to run on those resources or to wait, or what it's willing to accept with its own scheduling facility. And again, the key thing here is that you're dealing with a hierarchical scheduler, not just a single level scheduler for the entire resource pool of all the servers that you're working with. Now in this case, you can run Hadoop on Mesos itself, or there's a project in progress to run Yarn as a fully supported Mesos framework. And so in each case, each one of these has its own executor on the nodes. Each one of them can accept jobs and coordinate those resource offers through the Mesos scheduler and the corresponding scheduler for that particular framework. So we have different tenants, we have the applications that we need to build on. How are we actually going to stand this up? From my background at VMware, Serengeti was one of the earliest projects to be able to deploy multi-tenant Hadoop clusters, and in that case, multi-tenant meant that you could have different versions of Hadoop running on the same cluster. Again, they were in different VMs. They did not have to know anything about each other. When we're talking about multi-tenant frameworks within Hadoop, the tenant is the framework, and being able to run different types of application or different profiles or classes of applications on the same Mesos cluster, on the same resource pool. Now, within Serengeti, or within any of these blueprint mechanisms, we can specify the infrastructure layer, and we can specify a config management layer. Now, infrastructure for Serengeti is going to be vCenter, and that's pretty much it. The rest of the infrastructure functionality is not there for deploying to public cloud, so for vCloud Air, or for other cloud environments. That's probably the biggest single difference. So with Bosch, which is from Pivotal, which was derived from Cloud Foundry, because Cloud Foundry is a distributed system in itself, but didn't have a tool to actually deploy itself and its services and components across infrastructure, that's where Bosch came from. And Bosch is, or requires, a lot more explicit definition in its configuration file, but then is able to go out with that more specificity and deal with any cloud environment. This is what deploys Cloud Foundry. Certainly it can deploy Hadoop or Mesos and any other distributed system, as long as you understand the format of its configuration file and can match its specificity. Cloudify is actually using the Tosca open source blueprint framework. So this can work with AWS, Azure, vCloud Air, OpenStack, and again gives you a lot more flexibility in the cloud environment that you want to build out your environment, as well as being able to use Chef or Puppet to declare your configuration management. For Serengeti, that's only using Chef recipes, and also one of the nice things about Serengeti is that it does not require the same kind of specificity as some of these other frameworks, because it relies on DNS and DHCP and has mostly been focused on Hadoop to this point. However, there is Fling, which is an unsupported set of recipes that VMware has put out. So you can also deploy Mesos and Kubernetes onto a given vSphere cluster. Finally, CloudBreak is built for different cloud platforms and is mainly focused on the Docker form factor, as well as relying on Mbari to be able to deploy that framework. Still early days. I've run into several minor issues, but whenever CloudBreak is working, it's fairly slick, giving you the capability to spin up a Hadoop cluster on AWS and play around with that, be able to experiment with that. Now, for operations, obviously they want to be able to avoid siloing the infrastructure. Instead of dedicating infrastructure for some of the different frameworks, such as Marathon and Aurora and Hadoop and Yarn and other classes of applications which aren't necessarily encompassed by those frameworks yet, they want to have one large resource pool that they have to be able to manage, look at logging, and coordinate networking and service discovery. But at the same time, they want to be able to still give the developers their choice of framework, what they want to run under. If they want to run under Yarn, that's fine. If they want to run under Marathon, if they want to do other services, there's lots of choice there for them to be able to figure out what works best. And again, the key thing here is experimentation and decoupling their services so that they can make revisions to their part of the overall app pipeline without affecting the rest. And finally, again, the decoupling is really key for continuous integration and delivery so that they can test, figure out what makes the most sense for what they're trying to do. Whereas if they aren't allowed to do it, if they're restricted the amount of framework or what code they're allowed to use, they're going to be able to use that in a different public cloud, and then it's a reintegration issue later on, or potential migration further down the development cycle, and not able to maintain the same rate of release as they obviously want to take advantage of for new features and functionality. Now, the compute partitions in Mesos, again, this is all a shared resource pool. Each host is running its own executor to be able to spin up nodes within the cluster once the resource offers are determined from the slave or worker nodes. Then the individual schedulers can take advantage of that and deal with workload placement, service discovery, and overall coordinating how much of that overall resource pool it needs to get. For storage, a lot of these are already taking advantage of HDFS, which is great. If you check out on GitHub Virtual Elephant, that is Chris Muchler's repo, and also his blog, virtualelephant.com, where he talks about HDFS as a service and being able to build that out as a common substrate for these different services to take advantage of. Another alternative that Adobe is using is with EMC Isilon. Again, the Isilon serves as not just a file server, but is able to act as an HDFS repository for different applications to be able to pull data from and work with, as well as non-HDFS sources to be able to write to that, essentially that filer, and still be able to pull in or save that ingest step for the rest of the applications that want to be able to pull data out of HDFS. Now, working with networking services, the service discovery is actually handled per framework. So this could be DNS, this could be console, this could be one of the individual frameworks taking advantage of what it uses to discover whatever services are available in the networking fabric. For example, again, Marathon uses HA proxy, so it's better to load balance up front so that when you get ready to scale out, of course, you're dealing with a lot of homogeneous components, essentially the Docker containers that are getting deployed underneath. While you do get per container network monitoring, you do have ports managed by the Mesos worker itself, so that at least you have that, again, as a shared resource that you can portion out for the different frameworks to be able to take advantage of as they're spun up on the different nodes depending on their resource requests. Now, for the scheduling options, again, this is the key part of why not just use Yarn for your applications. Being able to take advantage of this hierarchical scheduling model gives the resource pool the opportunity to divide up those by capacity or by fair sharing across the different frameworks, and then be fairly specific because each framework will have its own scheduler that's able to determine what to do with those resources, whether it can accept those resource offers or what it needs to wait for, what it needs to queue, what it's able to do, again, within that shared resource pool in the data center versus just siloing that and having oversizing hardware for specific frameworks. To look at this from the developer's perspective, now that we've looked at operations, developers, their workflow is, pulling and pushing code from the source tree. Now, with Docker, they can provision not just the code or infrastructure as code. It's basically infrastructure as text files, and so they can push and pull the Docker container, which encapsulate the environment, so that they don't need to worry about what part of the overall cluster this is going to be running in. They've already got that much taken care of within the repository. Whenever they're deploying out with Marathon, for example, instead of with Hadoop, they can define sets of dependencies and health checks so that anytime they're upgrading services, anytime they're upgrading the versions within their containers, as that gets deployed out, they can set up the health check to slowly do a rolling restart of the containers that are already provisioned out in the cluster. And the automated build process could be part of Jenkins, it could be part of the Docker repo, either a public or private repo, to be able to track actually what they're issuing into the cluster at any given time, and key thing, being able to roll back if they're affecting the overall health in the system, but be able to deploy that code locally or deploy it into Jenkins to run through the automated test there. Now for the registry services, again, this is looking from a developer perspective. They want to be able to work on their portion of the overall system. They want to be able to, just like they are updating their code in the overall source tree, they want to be able to have those builds be automated, tested as much as possible, and then go through another round of testing once it hits the overall cluster, and quickly be able to determine their experimentation, see if this is valid, if this is working, what is the overall health of the system, is that negative, and be able to roll back quickly and figure out, again, deploying into production, what's actually going on, and have that all in a familiar workflow versus just trying to go through, deploy and build new VMs, cloning VMs, and ultimately the parts of the system may be deployed on VMs, but from the developer's perspective, they already have the OS and code and libraries and dependencies wrapped up neatly into their own container. So developers can use their interchangeable verbs. It's appreciated that they can be able to push and pull not just their source code, but the environment into the system, into the source code management, and actually have that deployed into the overall resource pool. They can have their choice of framework, whether they want to be able to do analytics jobs with Yarn, being able to do short-run services with Marathon, if they want to do long-running services under another framework called Aurora, which is another Twitter and Apache project. And also if they want to use something like Kronos for time jobs, which is basically distributed cron that's running under Mesos itself. And finally, be able to use the continuous integration, continuous delivery to discover whether their experimentation is working, figure out what makes most sense for the application overall. Now, again, since the name of the game is experimentation and self-service, you should be able to start small. You should be able to start on your laptop. You should be able to start working with your Docker container and be able to push it up to the repo, be able to push it into Mesos, and be able to scale out from there. And then evaluate the overall health of the system as it gets deployed, and then work on to the next component, work on the next service that you want to deploy and revise. We should be able to pick and choose our frameworks. Again, if Mesos is not compatible or not the framework that you're looking for, why not just use Yarn? So again, the name of the game is choice. So if you want to be able to provide your developers with these different frameworks, then Mesos is the easiest way to get there versus siloing that infrastructure for each individual component of that overall app pipeline. We need to be able to decouple those services, and again, the continuous delivery is going to be able to show this up really quick, where services aren't working together, be able to look at those very quickly and see what's actually going wrong, where those incompatibilities, but at least be able to deal with Docker container as that unit of work for that particular developer, and then start to debug the higher level services as soon as possible. And finally, make sure, again, as we're continuously working on the system, as we're updating the application, and different teams are working on different parts of the application at any given time, want to make sure we have capacity to give them to do that. And again, this may also play into the framework choice of how aggressive the scheduler is replacing instances, how we're doing those rolling restarts, what the actual health checks, and how we're taking advantage of Mesos at a high level for capacity scheduling. Now, of course, Mesos is relatively new, so we need to be able to look under the hood relatively often to see if things are going well or not, or be able to debug the services that are having issues. Again, if Yarn encompasses the scheduling and app requirements for 100% of your workload for your app pipeline, then that's great. The environments that customers that I'm talking to need to be able to deal with more of the outside frameworks to be able to deploy their applications, quickly do their testing, and quickly be able to evaluate what's going to work in production. And Mesos works as the overall resource pool to bring that together, so operations is not managing distinct siloed clusters along the way. Now, one of the other things that is not as rosy as working with or looking at some of the Mesos documentation is actually working with different versions of Mesos in the same, different versions of Hadoop or a given service within the cluster. So it's lucky Mesos does have a very growing community of developers working on features like that. And finally, security is still a concern, but at least this is still part of the software development lifecycle of the developers. And again, being able to work on security patches, security frameworks, and roll those into the Docker container, which are ultimately rolled into the overall system. And from the Mesos perspective, this is managed by operations, so at least we can work on Mesos as a shared goal from both sides of the equation. Finally, where do we still need to go with this? Obviously, still a lot to learn about the next generation of app pipelines and how all of these layers of the stack are going to play together, especially from an infrastructure perspective as well as from a developer's perspective. But the key thing, again, is choice, so that we can figure out what's the best tool for the job, figure out which framework it goes into, and leave the rest up to the Mesos scheduler and deal with that for the resource requests across the entire environment. Also looking at container OSs, so trying to take any other additional variables out of the equation. There's Core OS, VMware has Photon, Windows is going to have Nano, Red Hat has Atomic. So again, lots of different choices for actually trying to get to that container-focused OS, but still trying to remove out any other environmental dependencies underneath from that base template that we want to use. There's a lot of work still left to coordinate and automate the underlying network and services, service discovery. You know, some things rely on their own service discovery, some things rely on DNS. So obviously worth for operations time to investigate how that breaks out for each individual framework and what makes the best sense to scale and grow out in your particular data center. And finally, evaluate, put into a feedback loop what makes the most sense for each framework from a resource requirement and constraint perspective, whether you want to be more aggressive, whether you can be more aggressive in how you're delivering the resource offers to the constituent frameworks, or if you want to be more aggressive in the number of versions you're deploying. Again, all these things with the developer choice, you have a lot of potential for issues, but hopefully, again, as long as it's a joint effort, then you're delivering the most choice to the developers so they can build the best, most suitable platform that they want for their given application. And so just to wrap up, key things with Mesos, say one more time, is using it as the resource pool for the data center instead of siloing those physical resources, and also being able to accommodate this whether you're in a bare metal form factor or virtual form factor or in a cloud form factor, having one resource pool that you're working with that's scalable and portable across all those different environments, and being able to use Docker as that common unit of work for developers to take advantage of to deploy to different frameworks and also be able to experiment and figure out issues very early on in the process as they build out their application pipelines. So with that, is there any questions in the room so far? Yep.
How does Mesos work with requests from very long-running jobs? So you have, if you're running like a Hadoop cluster under your Mesos function base, this will ask for very long-running jobs, resource requests. And as far as I know about Mesos, it doesn't have a view about a global scheduling view.
Right, so question was what to do about long-running jobs in Mesos. So there is the Yarn Myriad project that's working on just encapsulating Yarn as a fully supported framework as a whole. Or there is the Aurora framework that is still in incubation but has a lot of folks from Twitter working on handling those long-running services. So again, there's options whether you want to deal with long-running services, again, with Yarn being the primary executor on that, or working with Aurora. So a couple different options to test around and see what fits your job case and what makes the most sense. Anyone else? Yes? Yep, so question about how do we compare on security. So ultimately the security is going to be a function of the developer software lifecycle, what they're putting into their code, as well as the attack surface of the container OS or the host OS, and the amount of services running. Right now, there are a lot of services that can be running and talking across the environment at any given time. Right up front, you should not be afraid to have the conversation with your security team and have them scan what's running, be able to lock down any other services, but there is a lot there that's running on Mesos today. So it's going to be operations responsibility and developer responsibility for ultimately what they're exposing at any given time. And of course, the other constituent services just as important around DHCP, DNS. This is a lot of things in motion at any given time. So security and network people should definitely be involved upfront and early about what you're building and what security issues, if any, they have with the overall system. And then hopefully if you're using a decoupled approach, then if it's particular groups, if it's their particular containers that they're exposing extra ports or extra services, then you can drill down from there.
That makes sense, but
Sure.
Are there any inherent security limitations within the Mesos Docker combination?
Again, it depends on what you're putting. I'm sorry. What are the inherent issues, or what are the inherent security issues of using Docker with Mesos? And I would say the inherent security issues are what exactly is in that Docker container, what exactly are you using for that code? Is it built in-house? Are you borrowing from someone else's code? Are you borrowing someone else's Docker containers to deliver that service? Is it being pulled from a public repo? Is it being pulled from a private repo? Where is that coming from? Who's looked through that source code? Who's evaluated what it's actually doing? Which is the same problem in virtual machines. So if you run arbitrary virtual machine appliance from someone else, then that's going to be whenever you figure out it's running extra stuff that it shouldn't be, or it could be running malicious code. If you have rights to deploy, an inherently poor or bad Docker container, it's the same thing as running an inherently poor virtual machine, because at that point, you're running someone else's arbitrary code on your system, and you should definitely, understand up front the security risks inherent in that. So it doesn't by itself, just running in a Docker container doesn't necessarily mean that it's more secure or less secure. It depends on what's in the container. One over here. Mm-hmm.
There are a lot of comparisons between Mesos and YARN. So Mesos is kind of a distributed scale, right?
Mm-hmm.
So you assign your resource to a certain type of application. Those resources are limited to not limited. It's fixed for that service. And that kind of resource, Mesos scheduler don't care how the customer's service schedule occurs. Like in the first several pictures, you mentioned there HDFS as a service.
Mm-hmm.
I mean, the cluster, we have a global HDFS plots on all the cluster. If we run YARN under the Mesos, and the YARN cluster wants to run some job and get some resource in part of the cluster, but there's some data on certain node that's not assigned to YARN, how you keep the data locality?
Right, so question is, how do we keep data locality if we're dividing up the services and decoupling, say, for HDFS as a service across the environment? So we can run dynamic partitions or static partitions in Mesos. So if you do want to keep data locality for the environment, then yes, I would run it under YARN, because again, it's understanding that inherently, so take advantage of that. If you don't have the same data locality concerns, or again, you want to be able to decouple the storage and compute layer so you can grow the storage independently of compute and have other services like Spark using that. Again, that's a question that you need to understand for your particular environment. For Adobe, they haven't even used the local storage for their production instance. It's actually running on Isilon. So it's not even local to the nodes. Again, the decision there was to decouple the storage service entirely, as well as skip an ingest step, because any data being written to the Isilon then became HDFS data. And they didn't see noticeable bandwidth issues for running their jobs across that. In your environment, you know, your mileage may vary, so definitely understand the trade-offs there. And I think we have time for one more question, if there's anything else. Okay, thank you guys very much. Have a good day.